So this is kind of slightly different from the previous examples, but we're now looking to evaluate at a point after we differentiate. So this will give us the gradient of a function at that point. So we're saying, what is the gradient at 2x of the function f of x equals this? So when this equation exists, what does its function, what is the gradient at 2x? Sorry, x equals 2. All right, let's go on and just work this out. So again, we'll write it in a nicer way. F of x equals 3x squared plus. Now, when you have something like this, where it's a power inside a root, you remember that the power always goes on top, and the roots will go on the bottom, like a plant. It's a way to think of it. It's not perfect, but that's a way to remember it. So you have x equals 3 to the power 2. So this is quite a nice way. We can start differentiating here. So f dash x equals 3 times 2, so that's 6. X 2 minus 1, so that's just x to the 1, plus 3 over 2, and then x, then minus 1 from 3 over 2, that just becomes 1 over 2. So, in the previous examples that was us done, but now we're asking what is the gradient of the function, and that is basically what the derivative of it is. We'll go on to explain that in slightly more detail in the front, but the gradient is just the rate of change of the function at that point. So what is the gradient of the function at x equals 2? So all we have to do here is substitute in 2 for wherever we see an x. So f dash of 2 equals 6 times 2. Right, one sec. Actually, 2 is not a good number to use. We're going to use 4 instead. Okay. Maths works out a little better. Okay, 4. So f of 4 equals 6 times 4 plus 3 over 2, 4 to the 1 over 2. So we know 6 times 4, 6 4s are 24, plus 3 over 2, and the square, so 4 to the half is the same as the square root. So the square root of 4 is just 2. So this equals 24 plus 6 over 2, which is the same as 24 plus 3. So that's just equal to 27. So the gradient of the function f of x at x equals 4 is 27. So I hope that those examples give you kind of a clear idea of how to use differentiation, slightly different, and can be ways with exponents and roots and 1/overs and stuff. So I hope that helps a bit.